In this question, we have two glass bulbs that are connected. They are left at atmospheric pressure and room temperature at first, but later one of the bulb is heated. So let's the amount of gas in this bulb be N1 and the amount of gas in this bulb be N2. I mean in moles, of course. So let's apply PV equals to nRT to the before situation first. So PV is nRT, right? So the pressure in both bulbs is the atmospheric pressure. The volume is actually the total volume, so it's a 0.4 plus a 0.2, so it's a 0.60 meter cube. The amount of gas, we are going to write it as N1 plus N2. R is of course 8.31, and the temperature is the common temperature of is of course 27 degrees Celsius. So the number we are putting in would be 300. It's actually 300.15, but it doesn't make much of a difference. So N1 plus N2, we know the total amount of gas is actually 24.06 moles. Okay, now let's look at the situation later when this guy's temperature is now at 327 degrees Celsius. So the temperature in the two glass bulbs are now different, but we know that the pressure in both glass bulbs is the same, because if the pressure is higher in one of them, then the gas should be going from the high pressure to the low pressure glass bulb. So the fact that there's no net movement of gases, that means everything has stabilized. We know that the pressure in both the glass bulbs should be the same. So it's the same pressure, so now we have to apply PV is equals to nRT separately to this bulb and then to this bulb. So let's do it for the first one. So P times V, which is the volume of this bulb here, is equals to nRT, right? So let's say that the amount of gas in this glass bulb is now N1 prime. So we have N1 prime here, and of course we have the 8.31 and the temperature of 300, 300. We can do the same for the second bulb here. So P times the volume, which is 0.2, is, let's say that, let's call the amount of gas here N2 prime. N2 prime, and again times the R and the temperature. The temperature of this bulb is different, is 327 degrees Celsius. So we got to convert it into Kelvin, which is 600 Kelvin. Again, that's a 0.15, but you know, as a percentage, it's not going to cause much of a difference. Okay, what we know is the total amount of gas here and here ought to be the same because no gas leaks, right? So it's still the same amount of gas that's trapped inside the two glass bulbs. So N1 prime plus N2 prime ought to be equals to N1 plus N2. We can write N1 in terms of P. So N1 is actually P 0.40 divided by the R and the T. Do the same for N2 prime. So that's a P times a 0.2 divided by 8.31, 600. So this should be equals to 24.06. So from here, you should be able to get the answer. The pressure is actually this amount. Okay, ta-ta!